Problem number 7 says the following. A wheel turns at a constant rate of 50 revolutions per minute. Okay, you can kind of understand that a car wheel, it revolves and it makes 50 revolutions in 1 minute, or any wheel for that matter. And the question is, through what angle in degrees does the wheel turn in 1 second? Okay, so the first thing is you got revolutions on the one hand and you got a minute on the other hand, and here you got second. Now we know that there are 60 seconds in 1 minute. So let's translate this revolutions into seconds. So you got 50 revolutions in 1 minute is the same as 50 revolutions in 60 seconds. 50 revolutions, okay, in 60 seconds. Now, what is a revolution? A revolution is 360 degrees. So we can say 1 revolution is 360 degrees. So it turns through 50 times 360, because each revolution is 360 degrees in 60 seconds. And the question asks, how many degrees in 1 second? So if this is in 60 seconds, so in 1 second, it's a question on proportion. It will have to be 50 times 360 divided by 60. Okay, in 60 seconds you have that, therefore in 1 second you have to divide, and straight away we can cancel. The zeros cancel, 6 turns cancel, 6 goes into 36 6 times. You don't have to multiply this. You can just treat it as fractions and cancel, and you have 50 times 6 at the top, which is 300. So that is 300 degrees, because we've now converted everything to degrees. So in 1 second the wheel turns through 300 degrees. That is the way we solve that problem. Okay, I'm going to send you the solutions because I've written out the solutions elsewhere. Like here, for instance, you will see that see, I've written it out completely, so you will get this as well. We'll put it out on the page after today's session. Okay, let's go on to problem number 8 now. In the diagram, ABCD is a square. Where is A now? A, let's just put a spotlight on this. A, B, C, D. Right, so that's a square. The sides of the square are 4 centimeters. So these 4 sides are 4 centimeters. Now, ABCD is reflected across the line AQ. So now we have a situation where something is reflected. Now, what does this mean? It means that AQ acts as a mirror, because you're reflecting it. So AQ acts as a mirror, and this entire square, the original square, is let me just change the color of this. Okay, so the original square is reflected across this line. Oh, there we go. All right, so you got a reflected line like that. This original square is reflected. So what this means is that if you think of this red line as a mirror, then B it looks at itself there. It has to be reflected to B prime. So this whole line is perpendicular to the red line, right? And it's the same distance from the red line. And it's the same thing with D prime. This thing here, or D. D went across here like this and went there. This is the mirror, two-sided mirror if you like. And the same with C, it went there. All right, so your new, what happens when you look at these four things, you get a different square here now. And the question is, what is the area of the quadrilateral ADQD? So if you look at the quadrilateral ADQD, we're looking at this quadrilateral here. ADQD prime, I'm sorry. ADQD prime. So what is the area of this? Now, we know the side, you see, we know the sides of the original square is 4. So ABCD is 4. Okay. And this is also 4. In fact, all these are 4. The squares are exactly identical because the one is being reflected across to the other. All right. So if this is 4, it means that this is also 4 here. Because this is a square, you see. And likewise, this is a square on that side. So this part here is also 4. Okay. All right. So I just want you to focus on these two triangles here. We need to know the area of this triangle. We have that is 90 degrees because it's an angle in a square. It was given that Q is the midpoint of CD. So CD, Q is right in the middle. So we know what this is. So that'll be 2, right? Because it's right in the middle. So what does this mean? It means that you've got a right angle triangle here. A side is 4 and the other side is 2. So we can easily find the area of a right angle triangle. It's half base times height. So the base is 2, half base is 1. 1 times 4 is 4. So the area of this triangle here is 4. Now, the question is, what is the area of this other triangle? Well, the point about this other triangle is that it's congruent to this left-hand triangle. These two triangles, the red line divides this thing up into two congruent triangles. Why? Because by reflection, these angles are the same. See? So therefore you got, in triangle here, you got a side 4, got a 90 degrees and a dot. And in the other side, you got 4, 90 degrees and a dot. So the triangles are congruent. And if they're congruent, they're exactly the same. All right, they only occupy different positions on the page, but they are the same triangle. So therefore, if this area is 4, so is this area. So that allows us to say that the area of the quadrilateral under investigation, namely ADQD prime, that area is 8. Okay, we'll have to say 8 square centimeters because area, the units are square units. Okay. All right, so tomorrow I'm going to do all these again with those people who missed out, unfortunately. We now got on to the next problem. The next problem is okay. So this problem says that on some island, which is named after a famous Greek mathematician, all vehicle number plates have 2 letters from the selection A, B, C, D, followed by a number 1, 2, 3, 4. This is like, We have some number plates like that in South Africa. In Gauteng, you've got letters and numbers, but of course the numbers come in the front, I think. The letters come afterwards. But this is a kind of simple kind of a situation. It's a small island with very few cars. And you've got the numbers are chosen from 1, 2, 3, or 4. That's important. The numbers are chosen from 1, 2, 3, or 4, while the letters are chosen from A, B, C, and D. So you can see the letters are A, B, or C, B, or D, D, but these two letters can be any of those letters. Okay. All right, so we understand the question. The question is, here you got any two letters from A, B, C, D, and here you got a number which is chosen from 1, 2, 3, 4. And the question is, how many number plates contain both a single A, you want one A, and an odd number, right? You want exactly one A and an odd number. All right, how does one go around trying to solve this problem? I'm going to go to a whiteboard. All right, and I'm going to draw this number plate, redraw it here. But I'm just going to put 3 slots because you need the first 2 are letters of the alphabet. I'm going to divide it up into 3 equal parts. Okay, and now you want a single A. Okay.
I'm sorry, sir.
The A could be here or here, but you need only one A. Okay, let's take firstly, let's suppose the A is here in the first square, right? A could be here and here. Then what happens? You've got an A here, and you get an odd number here. The numbers are chosen from 1, 2, 3, or 4, so an odd number can only be 1 or 3. And here you can have any one of the letters. But you can't have A because there's only one A. So you can only have B, C, or D here. Right? So we want to know now, how many such number plates are there? Well, the A is fixed there, so we have to choose from here. You can choose this in 3 possible ways. And for each such choice, you got 2 choices for this. Like for instance, you got B, you can put B1, B3, right? And of course, you got A in the front. Or you could have, right? If the letter was B, if the letter was C, you still have the same thing. C1, C3. First letter is still A. And you could have a D1, D3. So remember, that is if that first of the 2 letters is A, then we have 6 number plates. In the same way, if the second letter was an A, again, you will have 6 number plates for exactly the same reasons. So we altogether, you've got 6 plus 6 such number plates. You can either have A as the first of the letters, or you can have the second of the letters. In that case, you will have something like, for instance, you might have BA1 and so on. Right? So the answer is 12. Okay, so I want to get to the next one. Let me just stop and look at the chats just in case somebody is sending me a message, a couple of messages. Oh, there are lots of chats. Okay, so there are Okay, I think somebody said I got 12, and somebody says, no, please type it after he has explained it. So I think it's important. Don't just write down the answer and let everybody know what the answer is. If you know the answer, you can tell me after everything. All right. So some people now you see one person says A B and B A are not the same. That's right. That's a different number plate altogether. Okay. All right. So there are some comments here. Thank you for that. So let's go on to the next problem. Okay, so as I told you, we've written down the solutions in detail. Okay, problem number 10. Now, it's very important to read and understand a problem. You have to get a feel for what the problem is, read it and understand it, and then answer the question. That's the most important thing at the starting point. Understand it, so you know what is being asked for, right? So here we are looking at this question. Some three-digit numbers have the following property. All right, so we are talking about three-digit numbers, and we are looking at some of them, and they have a particular property. So let's see what the property is. The property is that if you remove the first digit, the remaining number is a perfect square. All right, so let's see now. For example, you got a three-digit number, and if this is taken away, you got a perfect square. In other words, you have a two-digit number which is a square, like for instance, 81 is an example of a perfect square. So it's quite possible that the last two digits is 81. Okay. So if you remove the first digit, then the remaining two-digit number is a perfect square. And if you remove the last digit, if this last digit is removed, the remaining two-digit number is a perfect square. So if this is removed, it's taken out, then this thing here is a perfect square. Let's take another example, maybe 36. Right? So what is the largest such three-digit number? So that's the question. Okay, so let's write down, the way to do this is we'll write down all the possible two-digit numbers which are squares in the front. So starting with 3 is a one-digit number, 3 squared is 9, 4 squared is this lowest one, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared. 10 squared goes into a three-digit number. These are the first two digits, right? Right. Now, so what will the last digit be? So they're asking which is the largest such three-digit number. So obviously, the largest will be, the first two are these. So the largest will be from here, isn't it? Okay. So what will it end in? It will end in, if you take the first digit out, it becomes a perfect square. So what number, one dash is a perfect square? Well, the answer is 16. So the answer is 816. That's going to be the largest such three. There are others, like for instance, this one here will be 64. See here, there's nothing here because no square ends in 5. But this could be 364, see? And so on. There are others. But we need not concern ourselves with those. We're looking for the largest, so we might as well go to the one which starts with 81. So that's the answer. The answer is 816. All right. So let's get on to the next problem. The next problem is So I'll give you all the solutions, but you can write as you go along. You can write for your own interest, so that you see, learning consists of three senses. Three senses must always be involved in learning, apart from the mind being active. Three senses are seeing, like what you're doing now, hearing, listening to me, right, and the sense of touch, the writing. See? So if you write and listen and see, then you consolidate all the learning processes. So if you want to write something in front of you, go ahead and do it, right? Because that will consolidate what you are learning. So the next one now is this question here. Bussy adds the lengths of three sides of a rectangle. So Bussy has a rectangle, and she adds the lengths of three sides. Now the rectangle has got four sides, all right? And she adds three. We don't know which three. She could be adding that, that, and that. Or you could be adding that, that, and that. Okay. But whatever it is, if she's taking three sides of a rectangle and she's adding it, in one case, she gets 73. And then she adds another three sides and she gets 77. And the question is, what is the perimeter of the rectangle? So evidently, she's missing out a side in one case. In this case here, 73, she missed out a side and she got 73. In the other case, she missed out a larger side. Okay, so when she missed out the larger side, she would have got 73. When she took out the smaller side, she got 77. So that tells us straight away that the larger side, this you have to think about, the larger side minus the smaller one is equal to, the difference is because in one case you got one large side and the other case you got one small side. And the difference between that is 4. So we could have, once you got that, then it means that the larger side is 4 centimeters larger than the smaller one. Now we don't know what the smaller one is. So this is a time when we can use an x here, and then we'll have an x plus 4 here. Because the larger side is 4 units, 4 centimeters longer than that. But this is a rectangle, so this is also x plus 4, and this is also x. Right? So if you take the two small sides, x plus 4, you're going to get, if you got two of the smaller ones, then you're going to get the smaller sum, namely 73. Okay, so you got an equation here now. This plus that is 73. But if I chose this plus that, I should have got 77. Okay, so what does this mean? You got 3x plus 4 is 73. So 3x is 73 minus 4. Take the 4 to the other side, and that is 69. So 3x is 69. So x will have to be 3x 69. So x is 23.
Excuse me, sir.
69 divided by 3. So now we have solved for x. This is 23. This will have to be 27. This is 23. And this is 27. And you can add you can work it out. And the perimeter of the rectangle is just the sum of all these. And you will see that you got 27 plus 23 is 50 times 2 is 100. So the perimeter is 100 centimeters, not square centimeters, because perimeter is the length. The perimeter is 100. Okay. Now, if you didn't like that, you would say, what is this 77 minus 73 and so on? I don't like the way that is done. I'd rather use proper mathematics. And this is the problem-solving strategy here, that you are
For
using
all
common
those who
sense
are wondering
to
if Sir
conclude that the
can hear
larger
us,
side is
don't
greater
think
than the
he
smaller
can.
side by 4 centimeters. That's problem solving. But if you want to just rely entirely on equations, then you could have done it this way. Yeah, let me go to my whiteboard. Okay, and then what you could have done is you could have said, let the sides be x and y. That might be the way that most people will understand. They say, let the sides be x and y. So let's call this x, call that y. So this has to be x, and this is y. Now you're taking 3 sides, they add to 73. Obviously, it'll have to be x plus y will be 73. The reason is that gives you the smaller sum. You got 2 x's here, you see. The larger sum will be x plus y plus y. If you took those 3 sides, then you're going to get 77. So these give you 2 equations, 2x plus y equals 73. And you got x plus 2y is equal to 77. And you can solve these two simultaneously, right? And solve these two simultaneously. How do you do that? It's in your syllabus. You could have multiplied, leave the first equation as it is. I'm sorry, this is 77. And multiply the second equation by 2 to make the coefficient of x the same. Right? That's the strategy. When you multiply 77 by 2, you get 154. And then now you can subtract the smaller one from the larger one. The 2x will cancel off. 4y minus y is 3y. 154 minus 73 gives you 81. And therefore y is 27, 3y. So again, you can come to 27 here, you see? And then you can substitute and you can get x to be 23. So you could have done it this way, right? Where you got 2 unknowns and you solve it as 2 equations and 2 unknowns, right? That's also a perfectly legitimate way, but I did it by using a more problem-solving approach. Okay, so let's just get on to the next problem. So problem number 12. Okay, now we got a problem number 13. So problem number 13 is saying, let me show this with you. This is screen 1. All right. Hopefully all of you can see the screen. If you can't see it, if there's any problem, please put your mic on and let me know, because I can't communicate with you at all. So let me know
Excuse me, sir.
If there is an issue, you can't hear me or something like that.
Excuse me, sir.
Sir,
Just one
sir,
moment.
can you hear? Sir, can you hear us? Sir, we can't hear you. Sir, Sir, can you hear us?
I don't think Sir can hear us.
All right. So here, problem 13 says a right angle triangle has hypotenuse length 20 centimeters. So here you can see the hypotenuse is 20 centimeters. One of the 2 unknown sides, or of the 2 unknown sides, one is 3 times longer than the other. All right, so you can see one is longer than the other here in the way we've drawn the diagram. And we know that one is 3 times longer than the other. So when you put mathematics to it, what we are saying is that if one side, we don't know what the sides are, so give a name to this unknown side, x, but you do know that if you call this x, the other one is 3x, 3 times longer. Right. In mathematics, in most problems, the idea is to come towards equations, right? And try to solve equations. But you have to build it up, take the information to create equations. So we normally try to target towards equations. Like in this case here, you know this is a right angle triangle. So immediately, you know that Pythagoras' theorem falls into place. So the square of 3x plus the square of x is the square of the hypotenuse. And the sum of the squares of the two adjacent sides is equal to the square on the hypotenuse. And now you've got an equation. This is 9x squared plus x squared is 400. 9x squared plus x squared is 10x squared. So 10x squared is 400, so x squared is 40. Okay, so we've got an equation involving x and we solve for x. I'm not going to simplify this because the problem is determine the area of the triangle. So what is the area? The area is half base times height. So it's half base, that's it, base times the height. It's a right angle triangle. So the perpendicular height is 3x. And then when you solve this, the numbers become 3 over 2. And x times x is x squared. And we know what x squared is. It's 40. So this is just 3 times 40 divided by 2. 3 over 2 times 40, which is the same as 3 divided by 2. And I don't multiply, I cancel. So 2 goes into 40 20 times, and 3 times 20 is 60. So that's the answer, 60 square centimeters. So you always put down the units. So the area that we're looking for, right, is half base times height, and you get an x squared in it, and we've solved for x squared using Pythagoras. So that is how you do problem 13. So let's go on.
Excuse me, sir.
Problem 14. That's the next one.
Sir, I don't think sir can hear us asking questions or see our questions.
Okay.
He needs to check the chat.
So problem 14 is another geometry problem. ABCD is a square and point F lies on BC. By the way, these problems, I didn't mention this, but it would have been on the first page of the questions. These problems are all last year's junior second round. So what we are doing is last year's junior second round. So the most recent junior paper is what we are tackling. In the sessions 2 and 3 and 4, I will do the junior second round 2019. Last year was 2020 and 2018. We'll do that and maybe some other problems as well by the time we come to session 4. But by the time we come to session 4, we would have finished maybe up to between 70 and 80 problems. We're now looking at problem 14. Of the 2020 paper. ABCD is a square. All the sides are equal, all the angles are 90 degrees. So just remember that. Right. And the point F lies on BC. Nothing is said about F. It just says F lies on BC. Okay. So triangle DEC is equilateral. Okay, so this triangle, this large triangle here, all the sides are equal, all the angles are equal to 60 degrees. And EB is equal to EF. So let me just put that down. EB equals EF. So this thing here is an isosceles triangle. EB equals EF. The question is, calculate angle CEF. Let's call that X. CEF. So that angle there, that's your unknown angle. Often even in geometry, I use algebraic symbols so that I can get equations and solve for X. So I'm going to call this angle X. It's X degrees, but I'm just going to put an X there. So the problem is to find X. All right, so let's try to move toward this X here from wherever we are. Okay, we know that this is equilateral, so this angle is 60. I'm not going to bother about those because they're kind of far away. But this thing here, this is 90, so this has to be 30. Right? Now, one important thing is that the equilateral triangle, all the sides are equal. But now you'll notice that one of the sides of the equilateral triangle is the side of the square. So this CB will be equal double stroke. So you got CB equals CE. Now that's an important point. So this is an isosceles triangle here. CB equals CE, and you know this angle here is 30 degrees. So that allows you to say the other two angles add up to 180 degrees. So you remove 30 from that, you'll get the sum of these two angles is that, but they are equal because this is an isosceles triangle. CB equals CE. So each angle will be half of that. So this 150 divided by 2 is 75 degrees. So this angle here is 75 degrees. But more importantly, this angle here, this entire angle here is 75 degrees. Okay. Well, I shouldn't have said more importantly. Just bear in mind that whole angle is 25. I'm going to actually erase that because that's coming in the way now. Because what I want to do is use the fact, I really need this one here, firstly. There's 75. Why? Because this is a base angle. CB equals CE. So each of these angles is 75. Now, it's given that EB equals EF. So you got another isosceles triangle here. So this should be 75 as well. Which means you got two angles of this triangle. They add up to 150. So this angle will be 30 degrees. Right? And now we can say that the angle, this entire angle here, 30 plus x, was equal to this angle here. Right? Remember, CE equals CB. So this whole angle is 30 plus x, and that is equal to 75 degrees. So you have this equation. So x will have to be 45 degrees. So that is how you solve that problem. You're starting with the equilateral triangle. Write down all the information that you know. You know, not everything, but all the pertinent information. Like all these are equal, and we target to see where are we going to. We want to get to this. So somehow we try to gravitate towards that. And you can see I started from here, I moved here, and moved there, and moved here, and moved there, until I came to the x. Okay, somehow you move towards it. So that's the answer to that question. The next problem is problem number 15. Okay, now what is 15? 15 says, a broken calculator doesn't display the digit 5. Okay, so you got a calculator which doesn't display the digit 5. So for example, if we type in 51258, the 2 5s disappear and only 128 remains with no spaces. Tobago typed a 6-digit number into this broken calculator, but only 2020 appeared on the display. How many 6-digit numbers could Tobago have typed? So now here we'll have to try to understand the problem. So let me first, like as I did before, I've got a 6-digit number. I like putting a big box here like this and write my 6-digit numbers into the box. So I'll make 6 little squares. So 3 on this side, and 3 on this side. All right. Now, this is the 6-digit number he typed. Now, what happened was that only 2020 appeared on the display. So what does this mean? It means that, well, the other 2 were wiped out. So you could have had the thing like this. In 20, the original number could have been like this, for instance, 20, 20. And these could have been 5s. You see? So if you type this number here, 250,250, then the 5s disappear and 2020 will remain. So what we are saying is that we don't know which 2 spaces the 5 occupied. Like in this case here, if the 5 occupied these 2 spaces, if the 5 occupied the second space and the 5th space, right, then you would have got that particular number. So how many possible digits did he have? Numbers could he have typed? Now you will agree that it all depends on where the 5s were. Now the 5s in this particular case are the 2nd and the 4th. Okay, so let's instead call it, instead of calling it 2nd and the 4th, we'll give symbols for these spaces. And let's call it, say, A, B, C, D, E, F. All right. The one that I had was B, E. If B and E were 5s, then the number would have been 250, 250. But the remaining numbers would have been 2020. So that's the choice I made. But now, how many such choices can you make? That is really the question. Okay, now we can actually count them. We can say, okay, the first one could have been an A, then the second one would have been AB, AC, AD, AE, AF. We could have had 5s in A and B, or A and C, or A and D, or A and so on. Okay. If A was occupied. Now, if B was occupied, we don't have to bring BA again, right? Because both of them will be 5s. So you can have BC, BD, BE, BF. Right? Or you could have had CD, CE, CF. These are the possible positions that the two fives could have occupied. Once you got the fives occupied, then automatically the number is obvious. Like for instance, if these were fives, then so all I have to do is to put 20, 20 in the remaining ones. And that will be that number that he had typed, 250,205, you see. So we really need to know where the fives were placed. And that's what I'm doing now. I'm counting CE, CF, and then DE, and DF, and finally EF. Now that exhausts all the possible ways in which you can choose two letters from 6. Now, here you got 5 plus, this way you got 4 plus 3 plus 2 plus 1, right? So interestingly, the total number of ways is 1 plus 2 plus 3 plus 4 plus 5. Okay, and that gives you 15. So these would have been the 15 possible numbers. There are 15 possible numbers because we've accounted for every possible situation, because the two fives can occupy any one of these places. So crucial to this problem is the number 15. How did you get the number 15? We added 1 plus 2 plus 3 plus 4 up to 5. Right, so in general, if I had, instead of having 6, when I got 6 boxes, I'm going to add 1 plus 2 plus 3 up to 5, and I got 6 boxes. If I had 8 boxes, then I would have had 1 plus 2 plus 3 all the way up to 7. Right? Exactly the same way. If I had 100 boxes, I would have had 1 plus 2 plus 3 up to 100, up to 99. See? So if you got n boxes, oh, this is n minus 1. So you're going to add up all the numbers from 1 plus 2 plus 3 all the way up to n minus 1. And in round 1, if you got good training, you would know that when you add up the first n natural numbers, then you're always going to get n into n plus 1 over 2, the sum of the first n natural number. But here you got the sum of the first n minus 1 natural numbers. So it's n minus 1 times the next one. This is, you're adding 1 to it. It's n divided by 2. So in general, I'm just going off. We already answered the question. We said that there are 15 such 6-digit numbers you could have typed. But if you had typed a 100-digit number, then we would have had, according to the formula, you're going to have 99 times 100. N minus 1 is 99, you see, divided by 2. So you would have had 99 times some big number. Right? And you get the 4,950 possible cases where he had 100 digits. Right? Okay, we just digress there a little bit. But for 6 digits, the answer is 15. And 15 is because you take n minus 1, which is 6 minus 1 times 6 divided by 2. 2 goes into 6 3 times. 5 times 3 is 15. So I could have used a formula to get to 15 without having to do all this. You see? That is why I went into that discussion. So the important result from there, which is used very often, right, is the following, namely the number of ways of selecting 2 objects from n objects it's a very important fact. I should have gotten the whiteboard. Oh. So this is an important fact. The number of ways of choosing 2 objects is an important fact. You can write it down. The number of ways of choosing two objects. Our objects here in that example are A, B, C, D, E, F. Two objects from n objects. There we had A, B, C, D, E, F. 6 objects is n into n minus 1 over 2. So that's an important fact that you should know, right? It occurs quite often in problem solving in juniors. So that's important for you to know that. So write that down because I haven't got that in the notes. All right, so let's move on to the next problem. The next problem is I'm going to clear this diagram. The number of ways of choosing two objects from n objects is n into n minus 1 over 2. Just remember that. So let's get on to the next problem. Okay, are we doing problem 16? Yeah.
Yeah.
Okay, problem 16. 3 large buckets have the same volume as 4 medium buckets, right? 5 medium buckets has the same volume as 6 small buckets. The question is, how many small buckets have the same volume as 15 large buckets? Look, this is a very easy problem. I'm going to go through this thing very quickly. So we'll call the large buckets L. The medium buckets, we'll call it M, a volume of a large bucket, the volume of a medium bucket, and the volume of a small is that 3 of these 3 volumes here is the same as 4 mediums. So that's your first equation. Then they say 5 medium buckets, 5 mediums is the same as 6 small, right? And the question is, how many small buckets? So how many small equals 15 large? How many small buckets have the same volume as 15L? So we want to know what is that. All right, so the way to do this is you got 3L equals 4M, so we can get 15L, right? You can get 15L by multiplying by 5 on both sides. 15L will be equal to 20M. Right. Okay, now you got 20M. Now 5M is 6S. Right? So 20M, you have to multiply this by 5, is equal to 24S. So that's the answer. How many small buckets have the same volume as 15 large? The answer is 54, 24 at least. See, so if you write the given information in the form of equations as I've done here, you see, you translate the language into mathematical equations. 3 large buckets, the volume will be 3L, is the same as, so you say equals, you see, 4 medium, so it's 4M. So like that, you got equations, and then you can solve these equations to get 15L equals 24S. So the idea is to create equations and solve it. And once you create the equation, then look how easy it is to solve it. So the most important thing is to create the equations from your story sum. And that's what problem solving all about. So now we get on to the more difficult ones. I think somebody said from problem 17 onwards, it became very difficult. So I think I put more in this picture than actually what the question said, but never mind. A rectangular prism rectangular prism. Now what is, firstly, you have to understand the language for this. A rectangular prism, what is it? Let me get on to a clear page here. Whiteboard. Okay, what is a rectangular prism? A rectangular prism is where the base and the top are rectangles. See? Then you get a vertical thing like this. So a box, for instance, is an example of a rectangular prism. There you'll only see this part here like that. Right. So the base, dotted lines to show that there is something in the background which we can't see. But this rectangle at the bottom is exactly the same as the rectangle at the top there. So that's what you mean by a rectangular prism. You could have had a circular prism. A circular prism will be similar, but now you'll have a circle at the top. Oh, it's not very neat. Now here you have like a Coke can. Now that's a circular prism, and this is a box, a rectangular prism. Okay, so let's get back to our question. Our question said a rectangular prism and there's a rectangular prism. This little piece here is cut out, you see, with two sides measuring 3 centimeters by 2 centimeters. So you got a 2 centimeters here, you got 3 centimeters, and this is removed. So this, you can see this picture here is quite nice. It's telling you this whole prism here, it was originally it was like this. See, there was a top, this thing was joined here, like that. And the top part was there. That was originally. But now this thing has been cut out and you got a hole like this. Now, if the prism had a surface area, if the original prism had a surface area of 96 square centimeters, what is the surface area in square centimeters of the new shape? Right? We've got only these sides here, 2 and 3. Okay, and what I've done here, this wasn't in the question, I put a B here to show that rectangle at the back. Right? The rectangle at the back has got the same as the area as the rectangle, which has got these 3 lines and this red line here. Right? The rectangle at the back is the same as this rectangle, so right in the front here. And likewise, the rectangle which you can't see on this side, okay, the bottom rectangle, the floor is A. So the floor is A, that rectangle is B. The one that we can't see here on this side, right, that is the same as this rectangle here. So we know that area is length times breadth, which is 6. So this surface area inside here is 6, and the one that we can't see is 6. And that one is B at the back, and you got a B in the front also. If the bottom is A, then the top part, which was removed, is also A. So this is another complicated thing. Let's see whether we can write our equations using the information that is given. Now, so they want to know what is the surface area of the new shape. All right. So in other words, you must add up all the top there and the sides and the front and the back and the bottom, right? And with the whole now, with these those two on this side here, that one and the bottom one. The top is removed and this front is removed, right? Remember that, because there's a hole here. Okay, so now how does one go around solving this problem? If the original prism had surface area 96 square centimeters, what is the surface area in square centimeters of the new shape? Okay, now this is quite a tricky problem. I just want to say the following. If you look at the shape of what we got here, you got A plus B, the bottom plus that one, A plus B, and these two sides, which is 6 plus 6, is the surface area of the whole. This part, 6 plus B, plus another 6 which you can't see, plus B again. No, this is empty, right? Plus A, the bottom one. So this is the surface area of the whole. Now, we are looking at not only that area, but what we will call the rest. All the other ones, this, that, and so on, the rest of it. Don't worry about the whole one, we have taken care of it. Plus the rest, right, is what we are looking for. They ask, what is the surface area of the new shape? So this is what we need to get. So we need to calculate A plus B plus 12 plus the rest. This is what we need to calculate. You say, what the heck? We don't know what these things are. But now watch very carefully. You see this B here. They say the original prism had a surface area of 96. Now, what was that? What was the surface? What is 96? 96 is all this part here, this rest, what we call the rest, plus this piece here which was removed, but that is the same as B. Right? So the removed part, the rest at least, plus this B, and then we must add even the top part of this, which was removed, which is the same as the bottom. Right? The top part here, which was removed, is the same as the bottom, will give you the original surface area. You see? Because all the other parts there, plus the front, plus the top of the removed prism, will give you the original surface. And we know that that is 96. You see? So that's very nice because we can calculate this. A plus B plus R is already 96. So this is 96 plus 12. Okay. 96 plus 12 is 108. Let me, somebody raise their hands. I just want to check that.
Sir?
Please. Somebody raise your hands. I've got so many people. Have you put your hand down? Somebody raised their hands apparently. Well, I cannot see any raised hands.
I can hear you, sir.
Okay, somebody, Sky Smith asked, wasn't the original shape 96? Well, all right. If you listen to me, I already answered that question. The original shape is 96. That's true. But we shouldn't be subtracting. Well, if you want, you can subtract 96 and do it some other way. But whatever method you use, you should come to 108 to be the surface area. This surface area of the new shape. It's 96 plus these two sides, 6 plus 6. Okay. That gentleman who's got that question, Sky, you can ask me at the end of the class, and we'll try to resolve that one if you still haven't understood it. Okay, because we've got 100 students here, so it's difficult to answer all the queries, but at the end, I can spare some time for you guys. Okay, so let's get on to the next one now. We now want to get on to the next problem. That was problem 17. We're going to go to problem 18. You can see the problems will be getting more and more difficult. Like this one here is another interesting problem. Okay, yeah, the problem says a school achieved a metric pass rate of exactly 96.8% without any rounding. What is the smallest possible number of pupils who did not pass? Okay, so the pass rate was 96.8. So the failure rate, you'll have to subtract this number from 100, you'll get 3.2, right? Those are the number of people who failed. But let's just work with the figures. If 96.8 exactly, so let's just assume this is the interesting part. When we make an assumption, and we'll see just now why. Because we want to get, so assume there were, okay, let me just take the black out, the red out. Assume there were 96.8, I think the best thing to do is to take 1,000 pupils. Suppose there were 1,000 pupils. Right? Then how many people passed? Yeah, you can see you're going to have a whole number. Number passing is 968. That will give you 96.8. 968 over 1,000 is the same as 96.8. Right, so if you had 1,000 pupils, 32 would have failed. Right? So the passing ratio would have been 968 out of 1,000 passed. But this can be simplified. You see, 8 can go at the top there when you check it out, and 8 can go at the bottom, and you get 121 over 125. 8 goes into this 1 to 1 times, and this cannot be simplified any further. Right, and this is also equal to 96.8. Right, and the question is, what is the smallest number of pupils who did not pass? So you could have had 125 pupils with 121 passing, and that's the smallest. You can't go anything smaller than that because you can't simplify this fraction. Right? So the smallest number of people who did not pass, these are the number of people who passed with the smallest population. So the smallest number of people who could not have passed is 4. 121 passed and 4 failed. Okay. So this is a good example of fractions and how to work with them. But the way the information is given, you have to interpret and use those fractions to good advantage to answer a problem. See? All right, so that's number 18. We want to get on to problem number 19. Yeah, that's problem number 19. So in this problem, angles DBC and ECB are both equal to x. So you've got, this is x, as you can see, the shape of an A. What is the sum of the three different possible values for y? They say triangle ABC, there's triangle ABC. It includes angles of sizes 48 and y degrees, right? So the angles in y, in triangle ABC, are 48 and y. Amongst these angles are 48 and y. That's all. And now, what are the sum of the three different possible values for y? Now, this particular question, it requires an understanding here because it's not easy to interpret this. So we're going to spend a short while explaining what's going on here using my whiteboard. All right, so I'm going to draw, they say there are three possible values for y. So let's see where's that coming from. So you got A, the figure is an A. I'm going to put three diagrams here because they say there are three possible values for y. Right. Now, what's important here is that these angles, the bottom angles were x, which means that these two angles are the same, this and this. Just remember that. This was x, this was x, so therefore these two angles are the same. Right. So these two angles are the same, these two angles are the same. Now, they say, what are the three possible values for y? The reason for that is y could have been here, or y could have been here, or y could have been here. There are only three places where y could have been, right? And in each case, we must find out what the possible value for y is, and you're going to add up everything. Now remember, they say that the other angle is 48. Now if this is y, these two angles are equal, so this would have been 48 here. 48, 48, right? In which case, y in this first example, 48 plus 48 is 96, and you subtract 96 from 180, you get 84 degrees. So this scenario gives you y equals 84. Right. In this case here, you got y and 48. Okay. Now, so what we've got here is 48 here and y here. So here you got 2y plus 48 . 2y plus 48 is 180 degrees. In this case, so 2y equal to 132 degrees. If you bring 180 minus 48 is 132. So in this case, y is equal to 66 degrees. Okay. And the last case is where this is y and this is 48. Um, okay, what is the last case? I seem to be getting stuck here. If this is y, then this is y again, and that'll be 48. I can put y, I can put 48 here. Oh yeah, I could have put 48 here. Two of the angles are 48. In this case, y is equal to 48. See? You could have had this case because they say two of the angles are 48. So one is y, one is 48. So this is a scenario that we haven't investigated yet up to this point. But then these two angles are equal, so y equals 48. So you got, these are the three angles, 84, 66, and 48. And if you add up all of them, 84 plus 66 gives you 150. You add up all the angles. They say, what is the sum of the three different possible values for y? Make sure you look at the question and answer the question. Okay, always be careful. Don't just put down some answer without, if it's got nothing to do with the question. Okay, so you got three possible values for y, and this is the sum of the three possible values for y. So that takes care of problem 19. And we will go on to problem 20 now. Okay, so this problem 20 here. What does problem 20 say? The ratio of boys to girls in a class is 2:1. One boy leaves the class and two girls join the class. The new ratio is 3:2. Okay, how many am I sharing the right one with you? It's a new share. Oh, okay, you don't have this one. Here we go. Right, okay. So this is what I was looking at. The ratio of boys to girls in a class is 2:1. And okay, let's start with that one. The ratio of boys to girls is 2:1. So what does this mean? Now, the ratio is one very important thing about ratios is that when you got a ratio A:B, right, you can say that this is A times X and this is B times X, where X is an unknown. Whenever you have A times X is to B of X, simplify that gives you A:B. See? So 16:24, for instance, is 8:12. Now, here you have to multiply this by 2 to get to that. So you multiply this by 2 to get to it. In this case, X is 2. 16 is equal to 8 times 2. 25 is equal to 12 times 2. So you always have this situation. So we can say, if the ratio is 2:1, we can say boys. So you can say let girls, number of girls, be equal to X. So the ratio of boys to girls is 2:1. So the boys would have been 2X. Right? So you got 2X X girls and 2X boys. Now, they give you information. One boy leaves the class and two girls join the class. So what happens now? When two girls join the class, the new ratio of boys to girls. So let's take a new ratio now. Okay, let's look at this. One boy leaves the class. So you got the boys at the bottom. So when one boy leaves the class, you got one less boy. And two girls join the class. Right? Originally you had X, but now you got X plus 2. And they say the new ratio of boys to girls, this is the new ratio, is equal to 3:2. So you can make this thing 3/2. See? So you have an equation. Right? That's the whole idea in mathematics. So again, I'll repeat this. When you got a ratio problem, you call one of them X and the other one you can work it out in terms of X as we got here. Right? And then you translate the given information. Right? One girl left the class, one boy left the class, so you got that number of boys, and two girls joined the class. So the new ratio of boys to girls or it's the other way around. This is girls to boys. Sorry. So you got the number of girls is 2, number of boys. So this ratio would have been 2:3. Sorry, it's 2:3. If I had boys in front, and I don't have boys, I put x plus 2 at the top. I should have had 2x minus 1 at the top. Anyway, you can cross multiply and solve this equation. 3 times x plus 2 is 3x plus 6, right? That way. And this way it's 4x minus 2. 2 times 2x minus 1. It's a nice simple equation. Solve for x. 4x minus 3x is x here. 6 plus 2 is 8. So therefore x is equal to 8. And how many pupils were in the class originally? X is 8. So there would have been 8 girls, and x is 8 and 16 boys. So altogether, how many pupils? Originally, got 24. 8 plus 16. That's the number of students who would have been in the class in the first instance. Let's just check. We said the 2 girls left, right? 2 girls joined. So what happens here is that the number of girls went up to 10, right? And the number of boys, 1 left. So the number of boys reduced to 15. And the ratio of boys to girls is now 15:10. And you can see 15:10 is the same as 3:2. So you can check to see that this is the correct answer. Okay, so again, you use equations to solve this and translate. Somewhere along the line, you have to use a symbol. And in this case, I choose the symbol to be x to be the number of girls, because it is said that the number of boys is twice that. So it makes sense to call the number of girls x. Okay. I think now I'm looking at this problem here. Problem 21. In the diagram, angles ABC and BCD are 90 degrees, right angles. AB is equal to 6. BC, this entire line is equal to 8. And CD is equal to 9. And the question is, what is the length of AD? Because this is 6, that is 9, and this is 8. Right, I think many people struggle with this one here from what I saw in the chat column in the beginning. So let's go back to my whiteboard. Right, and so I'm going to redraw this diagram on my whiteboard. So you got AB, and then you got BC is perpendicular like that. And then this is 9, so this is quite long here. Okay. And the question is, what is this line here? So that's the length that we have to determine. Okay, and it's also given that these are 90 degrees here. Oops. What happened here? Right, so this is 90 degrees and this is 90 degrees. And you are given that this is 6 and this is 8. Now this is a good example where you have to use a little bit of ingenuity to solve this problem. It's a good example of a problem solving thing. You see, this line here, AD, let me just get my symbols in place, A, B, C, D. Right, it says AD here. It's kind of an awkward line, but you can make AD the hypotenuse of a right-angled triangle. Then I can calculate it. I'll repeat that. You can make AD the hypotenuse of a right-angled triangle. Now how? So to do that, I have to extend this line for you. Sorry. I'm going to extend this line here. Right? I want to make AD the hypotenuse. I'll go up there and draw 90 degrees here. Like that. See? Now, so what happens now? You see? So if I draw 90 degrees there, you will see that we already know that this is 90, you see? So now you have a rectangle. See? And nice, useful to know that this is 8. Oh, wait a minute. This was 9. CD was 9. AB was 6. And this was 8, CB. But now you got that this is also 8. Because it's a rectangle, you see. If this is 8, the 8 has been pushed there. And then once again, this is a rectangle, so this is 9. So this will be 9. And there we have it. AD is the hypotenuse of a right-angled triangle whose sides are 15 on the one hand and 8 on the other. So by Pythagoras, we have that AD squared is 15 squared plus 8 squared, and that gives you 289. And happily, 289 has got a nice square root, which is 17. So that's the answer. The answer to this problem is 17. Okay? Okay, let me see. I just want to check with you guys. In problem 21, well, I don't have cylinder Kushler. You can ask me a question later on, or unless you want, no. I've still got 4 more problems and we are 2 minutes past 6. So let me just finish this and then you can ask me a question at the end. Right? I don't want to hold up people who need to go. Okay. Any questions we can raise at the end, all right? Please understand that because we started late, unfortunately, and therefore we have a problem. So let's get on to the next question, problem number 22. Okay, there's problem number 22. It says that Flood, what kind of name is that? Flood, Hagrid, and Sanjeev are running in a 1,000-meter race. They each run at a constant rate. After Flood has run 250 meters, he is 25 meters ahead of Hagrid. Then Hagrid, he runs 500 meters and he's 20 meters ahead of Sanjeev. When Flood finishes the race, how many meters behind him is Sanjeev? Rather complicated kind of a problem, but if you separate it nicely, let's have a look at them as they are running. Suppose they're running in a straight line. Okay. Now, they each run at a constant rate. When flood has run 250, I just want to focus on this part here. This part here. Why am I? Oh, I'm not sharing the screen. Hey, you guys didn't tell me that or maybe you did and I wasn't listening. Sorry about this. Okay. Oh God. I hope you had your questions in front of you. Anyway, let's just do this thing again quickly because I wasn't sharing the screen and you couldn't have understood what we were doing. So what we've got here is okay. When he has done 250, I just want to focus on this part here. He is 25 meters ahead of Hagrid. Now, here you say Flood finishes the race. That means here he is 25 ahead. When he finishes the race, he has done 1,000 meters. In which case, he would have been 100 ahead. Right? Because they're running the same pace. After 250, he's got 25 meters ahead. After 100, he will be 1,000. This is 4 times. 1,000 is 4 times that. So he would have been 4 times ahead. So this is what you've got here. It's like this. There's B. And there's H, and his finish is 1,000, and H would have just done 900 by that time because this is at finish. B is done is 1,000, running from here to here. His finish is 1,000. Hagrid is still at 900. Now let's have a look at Hagrid. What is Hagrid doing? When he does 500, when Hagrid does 500, he is 20 meters ahead of Sanjeev. 20 ahead. Sorry, let's just do it here. When H does 500 meters, he is 20 ahead. Of S, we'll call it S. But now H has done 900 meters. Now this is important. H has only done 900 meters. So how much ahead is he of Sanjeev? If 500 gives him 20 meters, then 900 will be 900 over 500 times 20. Now this is the crucial part. When he does 500, is 20 ahead. At 900, is 900 over 500 times 20. If you cancel these, 9 over 5 goes in 24 times, so it'll be 36. So it means that he is, at this stage here, he's 36 meters ahead of Sanjay because he's only done 900. And the question is, how many meters behind him is Sanjay? So V is at 100. He is 100 ahead of Hagrid, who is 36 meters ahead of Sanjeev. So V will be 136 meters ahead of Sanjeev. Of S. That's the answer. Notice there's no X's or Y's or velocity or anything like that. This is pure ratios. If you understand ratio and proportion well, you can solve a lot of problems. but you have to argue it in a logical way, like the way I've done now. Okay, so problem 22, this is the solution to problem 22. And the next problem is problem number 23. Let's go to problem number 23. Yeah, and there, problem number 23. So this is a rather curious problem. Well, you got a cat which is standing here, and you got a dog which is standing here, and the head of the dog is 180 centimeters, we'll just say 180, above the head of the cat. But if they reverse positions, if the cat stands there and the dog stands here, then it's only 140. And you might wonder, what happened to the remaining 40? It looks as if it's the same scenario. What's the difference with the cat is standing there or there, you know? But there is a difference. We'll see just now why. Okay, so now the question is now, what is the height of the table? Interesting question. Okay. Now, one way of doing this is if we give a symbol for the height of the dog and the height of the cat. Okay, let's just do that. We know what the height of the dog is. Let's call this thing X. And the height of the cat is Y. Right? Then so what is the height of the table? The height of the table then well, if you look at the thing, you can get the height of the table in two different ways. On the one case, the table's height yeah, okay, the table's height here is 180 plus Y, this whole thing, minus X. Right? And in this case here, the table's height is 140. Now here you got the X is here now, and the Y is here. So here you got 140 plus X gives you the whole thing, but you have to subtract minus Y, like that. So this is the height of the table. So if you put this as 180 minus 140 is 40, and this side, if you bring the X to this side, you get 2X minus 2Y. If you bring the X to this side and the Y to this side, you get 2X minus 2Y. So now this is interesting. This is 40 is 2X minus 2Y. So 20 is X minus Y, if you divide by 20. Now this is the height of the table. We calculate the height of the table in two different ways. And we've got X minus Y. I don't know what X is, what Y is, but I know what x minus y is. That's 20. See? So therefore, the height of the table is 140 plus 20, which is 160 centimeters. Okay, I'll repeat that. We give a name to the height of the dog, we give a name to the height of the cat, and we put the y in the correct place for the cat and x for the correct place for the dog. And we've got these two different pictures. And we know this height from here to here. So we can use this to calculate the height of the table. What is this height here? Well, what I'm saying here is it's equal to the entire height minus this part here. See? The entire height minus this. The entire height, if you look at this, is 180 plus y. But you have to take away the x. Now this is where we get this left-hand side. Now here again, the entire height, but this time minus y. The entire height is 140 plus x, but then you subtract y from it. So the height of the table can be calculated in two different ways, but you only got one equation with two unknowns. But if you look at it carefully, you'll see you don't need those two unknowns because you can calculate x minus y from that. And we don't need to know what x is, we don't need to know what y is, but you can calculate x minus y, so that gives you 160. Okay, and I have another very interesting solution here as well. This is the creative solution. Okay, what am I doing here? I'll show you the solution so you can see it. Now you see what I did now? I took the table and I brought it down to a lower level to the ground. See? I brought the table down to the ground, and then I calculated the entire height from top of the dog to the bottom in two different ways. See? Now, remember the table, but this time I said let the table be x centimeters. We say, we give a name to the table. We don't worry about the dog or the cat. We only worry about the table, right? So this is x, and it's the same thing is repeated here. So you have the d is the entire height. D is the distance. D is the height of the dog. All right, so you got d plus 2x. D is the height of the dog is d plus x plus x. So you get d plus 2x is the entire height from here to here. But you can calculate the entire height in another way by looking at this height from here to here, right? And adding the 140 from here to here. And then adding the height of the dog, see? Because you got 180 plus 140, right? Plus the dog. And again, you get x is 160. Think about this, right? That's a creative way. By pushing the table down, you could have calculated this thing, right? So you have two solutions to that problem. So there's your alternate solution, which I've done. Problem 24 is you've got three squares like this, and you need to calculate the length of BC. All right. So what we do is the areas are given. The area of the square here is 4, area of this is 36, and the area of this is 9. What I'm going to do is, to save time, I'll go straight to my solution and I will tell you what the solution is. I'm not going to work it out because it will take a long time to draw these diagrams. So I'm going to show you the solution and we'll just discuss the solution. So this is what we got here. The area of this was 4, which means that all the sides are 2. So I put 2, 2, 2, 2. Right? In this case here, the area was 9, this large one. I'm sorry, 16. Is it? 36, I'm sorry. The area of the large one is 36. So that is 6. Right? So from here to here, you got 2. We need to calculate BC, the whole thing. But from here to here, I've got 2. From here to here, I've got 6. Right? Because the area of this is 36, and the area of this was 9. From here to here, you got 3. And these are all squares. So you can see what's going on here. So the only things we don't know are this quantity here, this piece, and this piece. Right? And if you want to know BC, you simply add 2 plus 6 is 8 plus 3 is 11. And then you add these 2 small pieces. Now, can we find this piece here? Now, interestingly, this piece here, you can find it. And if you know graphs, now watch. When you did graphs, you draw a straight line here. And this, think of this as in a graph situation. You go horizontal, vertical. And the slope of this is vertical over horizontal, which is 2. The slope of this line is vertical over horizontal, which is 2. So therefore, then the slope of the same line, the slope of this line is still the same line. So the slope of this is also 2, but here the height is 2, so this has to be 1 here. Right? That will force the slope of this line to be 2 here, 2 over 1, and that is 4 over 2. The same kind of thing here for this. See? Here, the slope is 3 over 3 in that picture. So here too, the slope will have to be 3 over 3. So this part will also have to be 3 over 3. See? In this triangle here. Okay, in this triangle, you can see the slope is going to be 3 over 3. So it's going to be the same slope here, 3 over 3. So that gives you what this piece here, this missing piece is. And that is how when we add up all these things, you're going to get 15. 8, 11 plus 4 is 15. So this is the answer that is the length of BC. All right, so that is problem number 24. That was the penultimate or the second last problem. And the last problem is somebody was complaining that this is a very difficult problem. And it is because I gave it to many people and most people weren't able to solve it. So don't feel too bad if you didn't solve it. So this is the last problem which we're going to look at. Okay, so in this case here, the problem is you got a right angle triangle. Right? You got a side here with AB. And then you got this is 35 degrees, you got 10 degrees, you got 45 degrees. And you're asked to calculate the area of this entire quadrilateral. Now, I've given it to various people, and I myself have tried this thing, and I found a number of solutions. I think we've probably got about 5 solutions so far. But the best solution I got was this. In all cases, you have to have a construction, right? Some people can use trigonometry to solve it, but it's very complex. but a construction and solve it geometrically, it can be done. And I'll show you what the construction. There are many constructions. You can try to see whether you can get other constructions. That will be a nice exercise for you. As I told you, there are many constructions. But this construction, which I found to be very useful, is this one, which makes it very simple. And you'll see just now why we make this particular construction. You see, what I do is I create an isosceles triangle. You see, I got 20 here. So what I do is I extend this thing. Okay, it's not very, sorry about the little piece here. Let's just do this again. You know, here's the construction. I start from A. Oh, come on. And I'm going to create an isosceles triangle. I'm going to start from A. I'm going to put my pen down strongly here so it doesn't move. And I'm going to create, I'll go up to this so that I get 20 at the bottom here. Because I want to create an isosceles triangle. When you do that, you will see how beautiful the solution comes out. Remember, the problem is to find the area of this irregular piece. See, this entire quadrilateral. And you got all these 10 degrees, 45 degrees, all kinds of funny angles. Now, once you do this, the next thing to do is I'm going to join, I'm going to complete that isosceles triangle that I was trying to draw. Oh, sorry. Let's just get rid of this. And I'm going to come to this, like that. Now, this is 20, that is 20. So therefore, this is an isosceles triangle, as we've been claiming all this time. Right. Now, this angle here, so each of the angles must be 45. That's the point. Right. So if this is 45, then this angle here, this entire angle is 45 now. So this angle will have to be 10. Right? And we are almost there, because you have to now, you have to observe that there are two triangles here which are congruent. That's a beautiful thing. You got triangle BDC is congruent to triangle DBA. Right? We're looking at these two triangles here. That one and this other one here. The whole thing going up to this. Those are the two triangles. Why? This angle here is, this side is common, DB. And this angle here we saw was 10 degrees. And is equal to one of the angles here. That's also 10 degrees. And it's given that this is 45. So you got that angle is equal to that angle. So you got two angles and a side. Right? So the triangles are congruent. And if they're congruent, they must have the same area. So this triangle which is shaded at the top, its area is the same as the triangle which is shaded at the bottom. Now watch. The shape that we are trying to find the area for is the this triangle plus this white triangle. Right? The white triangle plus this shaded part is the area that you're looking for. The area of ABCD is equal to triangle ABD, that's a white triangle, plus the area of that part there. But we just shown that this triangle is the same as the area of this, the other triangle is congruent. So you're finding the area of this plus area of triangle BDE. We call this point E. Oh, BDE. Oh, I'm sorry, I should have. BDC, DBE. Sorry, shouldn't have been DBA. It's DBE. This point here is E. Now, when you look at the white plus this other triangle, you'll see that this is exactly the same as the area of the triangle ABE. Because this white triangle plus the other white triangle gives you a triangle now. It's a triangle ABE. But ABE is an isosceles triangle whose sides are 20 and 20, right angle triangle, right? And that area is equal to half base times height. The base and the height are the same as isosceles, and the answer is 200. So problem number 25, the area is 200. There are many other constructions that you can do. As I said, you can try out some other things and try to prove this in various ways. But this one here, the problem is that it's very hard for you to see that this is the construction. You need to make a construction to solve the problem. And I only solved this construction after I solved the problem in some complicated way. So it's very unfair to think, why should you complete the isosceles triangle? There's no reason for you to do that at all. But it turns out that when you do, everything falls very nicely into place, right? But intuitively, it's not easy to see that that's the area, that's the thing that you're going to look for. Intuition will demand something else, right? But maybe some other time, we will say what the intuition will demand. See, I have given you another alternative solution. The solution that I had here was something which was different. It was this one here. See, I had some other construction. See, we put some other thing here on top of this. We didn't draw this isosceles triangle. And this was a long proof here. This took much longer. This is my first attempt at this thing. But later on, I saw that the one that I just did now is very much easier. Okay. And oh, yes. Oh, I did put this alternate solution here as well. Okay, guys, that brings us to a close.